Have you ever looked at an old piece of tech and thought, I can push this further. I can make it do things it was not meant to do. I had this perfectly good 7-year-old Android smartphone and I got this glorious, terrible idea. Could I manually force it to dualboot 2 different versions of Android? No easy tools, no automated installers, just me, a command line and a whole lot of confidence. How hard could it be? Well, I tried it and it failed. Then it failed again in a different way. And then it failed a third time in the most confusing way possible. The story of why it kept failing is the real treasure here. Stick around. The prep work was straightforward. I modified the phone's TWRP recovery source code to add my own dual boot menu with buttons and custom scripts and compiled it. And I partitioned an SD card to hold my second OS. I created 3 partitions, one of 128 MB for boot partition, 5 GB for system partition, and the remaining for user data. My confidence was high. For my first attempt, I got ambitious. My main ROM is Android 7, but I want to try dual booting a newer Android 8 ROM, OmniROM. I copied the zip file of my second ROM, then went into the dual boot menu to install the second ROM to the SD card using my custom scripts. It failed for some reason. TWRP does not execute scripts properly, I don't know why. So I had to manually write the images to the SD card using my computer. I copied the files, used the command line to swap the boot images and hit reboot. And I was immediately met with failure number 1, the black screen of nothing. I saw the splash screen, then no boot animation. It wasn't a boot loop, it was just dead. Okay, so that was my first lesson, and it was a big one. On these older pre-Treble phones, you cannot simply run a kernel from one major Android version on the firmware of another. The Android 8 kernel I was trying to use was totally incompatible with my phone's Android 7 hardware drivers. A rookie mistake. Time for round 2. No more mixing versions. I chose Viper OS, a ROM based on the exact same Android 7.1.2 as my main ROM. The versions matched. The logic was sound. This had to work. I repeated the entire process with the new ROM. And this was failure number 2, the splash screen freeze. This was completely different. The phone wasn't dead. It was just stuck in purgatory. I can still see the charging indicator when I plug it in. It was a kernel panic. The core of the OS was crashing before the boot animation could even start. But why? The versions matched. I thought maybe this particular ROM was just faulty or corrupted. To test that theory, I needed a control experiment. I chose a third ROM, Resurrection Remix. The key here is that I knew this ROM worked perfectly on this phone because I had used it as my daily driver in the past. If this failed, the problem wasn't the ROM, it was my method. And there it was, failure number 3, the exact same kernel panic. That was the aha moment. When a ROM you know is good fails in the exact same way, you found your culprit. The failure was happening so early in the boot process that it had to be a fundamental conflict. And that led me down the rabbit hole to a single critical file hidden inside the boot image, the FS tab. Naturally, I unpacked the boot image of my second ROM using Android Image Kitchen, AIK. Upon inspecting the FS tab file, things became clear. The FS tab is the map that tells the kernel where to find the rest of the phone's partitions. And it was pointing to the internal storage partitions, not the SD card. So, I edited the paths to point to the corresponding partitions on the SD card. I also discovered that the stock FS tab contained security flags that were likely telling the kernel to look for keys on the internal storage. When the kernel was told to boot from the SD card, it could not find those keys and it went into panic. I had been giving my kernel a map that was leading it directly off a cliff. But here's the kicker. Even after figuring all of that out, I realized that my simple FS tab hack was just scratching the surface. You see, the kernel was likely searching for other partitions like the vendor, cache, NVRAM and whatever these partitions are on the internal storage, but none of this was matching with the Resurrection Remix's files, only finding files related to Lineage OS, my main ROM. That's why it is almost impossible to toolboot these pre-Treble devices. Which brings us to the genius of a legendary tool called multiRom. multiRom didn't just reboot the phone, it used a specially patched kernel with a feature called kexec. It would load the second kernel into memory while the first one was still running and then jump directly into it, completely bypassing the device's bootloader and all other problematic hardware checks that were causing my kernel to panic. So I failed, but the journey was the reward. I ran headfirst into the very limitations that led Google to re-architect Android with Project Treble. Project Treble's core idea is to modularize Android. It separates the Android OS framework from the vendor implementation, the device-specific code. This made updating the OS so much easier. Previously, when Google released a new Android version, vendors had to wait for the chip manufacturers to update their low-level code to be compatible with the new Android version. Only then could they begin adding their UI and features into the OS and releasing it. As you might have guessed, this is extremely slow. My device was a pre-Treble device, meaning the device-specific low-level software and the main OS were tightly bound together, which made dual booting almost impossible. My failures were a history lesson, and I now have a profound appreciation for the engineering that goes into making these devices work. The project was a failure, but the experiment was a total success. Thanks for watching, and I will see you in the next one.